Hello all. In today's lecture, we are going to see about NAND and NOR implementation. You very well know NAND gate and NOR gate is called the universal gate. But why is only these two gates called universal gates? And what does a universal word meaning? Universal meaning multi-purpose. What does it mean? A single gate, if it can be used for multiple purpose, then that gate is called the universal gate. Say for example, if we have different kind of applications like if you want to design a multiplier, or if you want to implement a subtractor, or if you want to implement an adder, every application has got its own logical expression that you know. You cannot use the adder expression for implementing a subtractor, or multiplier expression for implementing a subtractor or an adder. You agree with me in that? Every application has got its own logical expression, right? And based on the logical expression, based on the number of variables that you have in the logical expression, the number of gates required for implementing the circuit also gets increased. That is, for example, if you take a multiplier, let's take the example of a multiplier. For implementing a multiplier, what all gates are required? You need a NAND gate because you're doing a multiplication, and you need OR gates because you have to do the addition as well, right? And how many number of gates you require? You need just one gate or you need multiple gates? It depends on the number of variable inputs that you have, right? So the more the number of variables, the more the number of gates are required. The more the number of gates are there in the circuit, obviously when designing the circuit is going to be complicated. This is one reason. Apart from this, with the increasing number of gates, the cost is also going to get increased, right? Just imagine if you can replace all this different type of gates with just one single type of gate, rather than using a variety of gates like AND gate, OR gate, NOT gate, and so many gates inside the circuit. Rather than that, if you're going to make use of a single gate, and if that single gate can do all the purpose, then obviously the complexity is going to get reduced, and the cost is again going to get reduced because you're not going to use different type of gates. You're going to use only one single gate. If this single gate can replace all the gates that you're using in your circuit, then that gate is called the universal gate. Here, NAND gate and NOR gates are called the universal gates because these two gates can replace all the other gates in designing in your circuit. What are the gates that we saw in a previous class in logic gates lecture? We saw about OR gate, NOR gate, AND gate, XOR gate, XNOR gate. In this lecture, we are going to see how NAND gate and NOR gate is used for replacing all these gates. How you can replace OR gate with NAND gate or NOR gate. How you can replace NAND gate with NOR gate or NAND gate. We are going to see how all these gates can be replaced with just these two gates. Fine. Now let's see how NOR gate can be replaced by NOR gate and NAND gate. Fine. How do you design a NOR gate? What is NOR gate? NOR gate is called as a complementary gate. Whatever input you give, the output is going to be the complement of it. Right? This is NOR gate. We are going to see how this NOR gate can be replaced with NAND gate now. How do you represent a NAND gate? NAND gate is normally represented like this, right? Where these are the two inputs. But we want to see how NAND gate is replacing the NOR gate. For a NOR gate, we have got only one input. So we have to make this two input as a single input. How do you make that? You join both the inputs and then take a single input. Fine. Now what an AND gate normally does, it does a product of your input and then the complement of your product is going to be your output, right? For a two input. But here we have got only one input. So there is no need to do any product. It is just going to take the complement of it. Whatever input you are going to give, the output is going to be the complement of it. Here, this is how the NAND gate will replace a NOR gate. In a similar way, let's see how we are going to replace this NOR gate using NOR gate. How do you represent a NOR gate? NOR gate is like this, right? And these are the two inputs. But for a NOR gate, we have got only one input. How can you make this two input as a single input? Join both the inputs and then take a single input. Clear? Now, whatever input you are going to give, what does a NOR gate normally do? NOR gate does the addition of your input and the complement of that addition will be there in your output. But here we don't have any two inputs. We have got only one input. So whatever input you are giving, the output is going to be the complement of that particular input. So this is going to be my output. Clear? How we are replacing this NOR gate by NAND gate and NOR gate in the circuit. Fine. Now, let's see how to replace OR gate with NAND gate and NOR gate. Clear? How do you normally represent an OR gate? OR gate is nothing but the addition, that is the sum. When A and B, output is equal to A plus B. Correct? This is my OR gate. Correct? Now, let's see how to replace this OR gate with NOR gate. A and B are my two inputs, the same inputs that I am taking. So what is the output of my NOR gate? It is A plus B the whole bar. Right? If I am replacing OR gate by NOR gate, what does it mean? The same operation should be done by NOR gate, right? So to make the NOR gate same as OR gate, I am going to take this output and again I am going to feed it as an input to another OR gate. Whatever input I am getting, I am giving here, this NOR gate will take the complement of it, right? So it will be like this. As per De Morgan's law, A double bar is equal to A. Correct? Both the complements will get cancelled out. So this can be written as y is equal to A plus B. Right? This is same as my OR gate. Right? This is how NOR gate will be replacing your OR gate in your circuit, whatever circuit you are designing. Fine? Clear? Let's see how to replace this OR gate with NAND gate. How do you use a NAND gate for replacing an OR gate? For that, take the complement of every single input. A is one input, the complement of it is A bar here. And then I am going to complement my other input as well. B input I am going to complement and that is going to be B bar. Fine. Both these two outputs I am going to feed it another NAND gate. So what is the output of this NAND gate? It is A bar dot B bar the whole bar. What does a NAND gate do? NAND gate takes the product of the input to that particular NAND gate and the complement of that product is going to be my output. Here A bar is the input to this particular line and B bar is the input to this particular line. Right? Now NAND gate is what? It will take the product of its input. So what are the inputs? Here it is A bar and here it is B bar. So it will take a product of both the inputs and since a bubble is here it will take a whole complement. Right? Now let's solve this. Y is equal to A bar dot B bar the whole bar. Correct? According to De Morgan's law, we'll split it up. While splitting, it becomes A double bar plus B double bar. You very well know A double bar is equal to A. So can I replace it as A plus B, which is same as my OR gate. This is how you will be replacing OR gate with NAND gate in the circuit. Is it clear how to replace OR gate with NOR gate and with NAND gate? Clear? Now let's see how AND gate can be replaced with NAND gate and NOR gate. Fine? For AND gate, what is the formula for AND gate? It is y equal to A dot B. Right? Now let's see how this AND gate can be replaced using NAND gate. The same inputs I am taking. What is the output of NAND gate? It is A dot B the whole bar. Correct? To make the output of NAND gate same as AND gate, I am going to feed this inside another AND gate. So my output of this will be A dot B double bar. Here, if you solve this, both the bars will get cancelled and I will be getting the same output as that of NAND gate. This is how I will be replacing AND gate with NAND gate. Clear? Now let's see how NOR gate can be used for replacing AND gate. Every single input I am going to complement it here and here again. Every single input, B input again I am going to complement. Both these inputs I am going to give it inside another NOR gate. So what is the output of this NOR gate? It is going to do the sum of both my inputs plus complemented since I have got a bubble here. Now solve this. This is A double bar dot B double bar. Correct? When I cancel out, say A double bar is equal to A as per the De Morgan's law. So it is same as A dot B. It is same as my AND gate. Here, how to replace this AND gate with AND gate or with NOR gate? Now, let's see how we are going to replace XOR gate with NAND gate and NOR gate. Let's see how to replace XOR gate using NAND gate and NOR gate. What is the formula for XOR gate? Y is equal to A B bar plus A bar B. Correct? Now, let's expand this first. For implementing using NAND gate, let's see how this can be implemented using NAND gate first. What is the formula? Y is equal to A B bar plus A bar B. Right? Can I write this as A B bar plus A bar plus A bar B plus B B bar? You know A dot A bar is equal to 0. As per the postulates that we saw in Boolean algebra topic, A dot A bar is equal to 0. So this is equal to 0 only. This is again equal to 0. So can I expand this like this? Now, from these two terms, which is common? A is common. So I'll take A outside and I'll write it as A bar plus B bar. Clear? And from this term, which is common? B is common. So I'll take B outside and I'll write it as A bar plus B bar. Clear? You also know A, B, the whole bar can be written as A bar plus B bar. Right? Now, the same thing I'm going to write. I'm going to replace this with A, B, the whole bar plus B into same A, B, the whole bar. This entire term I'm going to replace it with this term. Clear? Based on this. Now, we are trying to replace this XOR gate using NAND gate. And in NAND gate, your output expression has to be a full product term. Shouldn't have any sum term, right? Only then you can implement using NAND gate. NAND gate meaning it is a product, complement of a product, right? So your final expression has to be only product term. So when you see here, this is a product term, and here again it is a product term. These two again product term, and B with AB bar. This again is a product term, but in between you have only one plus term. That plus term again we have to change it to product for implementing using NAND gate, right? So how do you replace a plus? If you want a plus, get changed to dot. What do? You take a complement of it. In a similar way, if you have a dot product and you want to change it to sum, then you take a complement of it. Complement of plus is dot, complement of dot is plus. Here we have a plus. We wanted to change, right? When you're taking complement, you cannot take it only for the symbol. You have to take it for the entire expression. How do you take it? It is A dot now. B the whole bar. Why have we taken this bar and this bar for this term? Let's try to solve. While solving, you should get this term, right? Only then your expression is correct. Let's cross check. A bar B, the whole bar dot B, A bar, A B bar, the whole bar, the whole bar. Right? If I'm splitting it into two groups, then it becomes A bar B, already one bar dot plus B, A bar. Correct? Now both these two bars will get cancelled out. So what do I get? A into A bar B plus B into, right? Have I got the same term here? Whether this term and this term is same? Both are same, right? So can I replace this with this? Here when you see, the entire final expression is only product term. Correct? Now, this is my final expression. I want to implement this final expression using NAND gate. How do you do that? For implementing, always start from the middle term, AB bar. I am taking AB bar here. What is the output of this? This is A and this is B. Right? And the output of this is AB bar. You know, AND gate meaning it is product gate. OR gate meaning it is sum gate. And NOT gate meaning it is complement gate. Keep this in mind. NAND gate meaning the complement of product, NOR gate meaning the complement of sum. Clear? Now, since A and B we have to do a product, so I have taken AND gate. Product is AND gate, so I have taken an AND gate. and on top of it you have a bar. So whenever you find a complement, you have to put a bubble. Clear? Now, A, B bar, I've got it here. This term I have to do a product of that with A, right? Here. So I have A here. Let me take A from here, and with that, with A, I have to do the product of AB bar. AB bar is here. So these two I have taken, and I have to do a product. Product meaning it is AND gate. Clear? So I have done a product. Now, after doing the product, there is a whole bar on top of it. This bar. For this bar, I'll put a circle. Clear? So what is the output of this here? It is A dot AB bar, the whole bar. Clear? A is this, AB bar is this. I have done a product of this. Along with this, there is a whole bar here, so I have put a circle here. Clear? In a similar way, let's do for this again. Here it is B. I am doing a product of B with AB bar. So B is already here. Let me take B here, and AB bar is coming from here. These two terms I have to do a product. I have done a product now. And on top of it there is a bar, so I'll put a circle here. Clear? So what is the output of this? This is B and this is AB bar. Product of both my inputs, B dot AB bar, the whole bar. Clear? Now I've got this term, I've got this term also. These two terms, what have I done here? I've done a product. So the output of these two terms, let me take it, and then I'll send that to a NAND gate. Why NAND gate? Because there is a whole bar common to both the terms. Clear? So this is my final bar, which is nothing but my XOR. Is that clear? How to replace an XOR gate with an AND gate? This is how you will be replacing it. Clear? Now, XNOR gate. What is XNOR gate? We'll say XNOR gate also. XNOR gate you very well know. XNOR gate is a complement of XOR gate. Right? So the output Y, whatever I have got, if I send that inside an AND gate, then this becomes an XNOR gate. Sorry, this becomes an XNOR gate using NAND gate. Is that clear? Whatever Y input I have got here, till here it is XOR. If I take the output of this XOR gate and feed it inside another NAND gate, then this becomes my XNOR. Clear? This is how you will be replacing XOR gate and XNOR gate using NAND gate. Fine. Now let's see how to replace XOR gate using NOR gate. Now let's see how to replace this XOR gate using NOR gate. Fine. Write the same expression. For XOR gate, what is the expression? It is A B bar plus A bar B. Right? The same way. Try to expand it by writing A bar plus A bar B plus B bar. You know A bar is 0, B bar is 0. Right? A dot A bar is 0. You very well know that. Fine. From these two expressions, which is common? A is common. So it is A bar plus B bar. And from these two terms, which is common? B is common. So it is A bar plus B bar. Clear? Now, what does NOR gate meaning? OR gate meaning it is sum gate. So a final expression should have only sum terms. There shouldn't be any product term. Here, can I write this as like this? Can I write this expression like this? Now when you see, this is again a sum term, this is again a sum term. You have only one product term in between. This product term has to be converted to a sum term. Only then we will be able to implement that using NOR gate. Let's see how to do that. For that, again, except taking a complement. This can be replaced by you can replace this expression like this. If you want to cross check again, you can do that. A plus B double bar dot A bar plus B bar double bar. Here double bar and double bar will get cancelled out, so it will be a plus b dot a bar plus b bar. I've got my same answer. Clear? So this is going to be my final expression which I'll be implementing using NOR gate now. Let's see how to implement that using NOR gate. For this, let's take a plus b first. I have two inputs a and b. Output of NOR gate it is a plus b the whole bar. A plus b the whole bar. So I have finished drawing the logic diagram for this particular term alone. Now let's do for this. Here it is a bar. I have only a. So I have to convert that to a bar first. So let me convert that to a bar. So the output of this is a bar. Clear? In a similar way, a bar I have done. Now I have to do for b bar. B bar again, let me do it. Here it is b bar. So b bar again I have done. A bar plus b bar. A bar and b bar both together they are summed it up. So the output of a bar and b bar has to be summed up here. So what is the output of this? This is a bar plus b bar, and you have a bubble here, so it is whole bar. Now have I got this entire expression? A bar plus b bar the whole bar. So this entire expression is also done. Now this term I already have it here. This term I have it here. Both the terms, what have they done? They have done a sum. So both the outputs, this output and this output, both these two outputs you have to give it to a NOR gate. Why NOR gate? Because there is a whole bar here. This OR gate will do the sum, and this bubble will take a whole bar. This bubble will take a whole bar, this bar. Clear? This is how you will be replacing an XOR gate using NOR gate. Fine. In a similar way, for XNOR gate. XNOR gate is nothing but XOR, complement of XOR gives you XNOR. So this is the output of a XOR gate. If I want to find the XNOR gate, what do? I'll give this input to another NOR gate. So this will be my XNOR gate. This is going to be my XNOR gate. Is it clear? How to replace OR gate, AND gate, NOR gate, XOR gate and XNOR gate using just NAND gate and NOR gate. Whatever might be the gates that you're going to use in a logical expression for designing your circuit diagram, you can replace the gates, the different type of gates that you're using in a circuit by just NAND gate or NOR gate. To simplify and to reduce the complexity of that logical diagram, you can replace all the gates that you're using there using just any of these two gates. That is why NAND gate and NOR gate is called the universal gate. Is that clear? I hope you are clear with the concept. If you find this lecture useful and informative, please do like, share and subscribe to my channel. Thank you.